Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P16BC, refers to a low voltage issue in the alternator FR terminal circuit or the ignition power IGP circuit. This code is associated with the Honda Civic models manufactured between 2006 and 2011. The alternator is a crucial component that generates electrical power for the vehicle while it's running and recharges the battery. An underperforming alternator can lead to various electrical problems, affecting performance and reliability. When troubleshooting this DTC, it is vital to gather all available freeze data and onboard snapshots, which provide valuable information about the vehicle's operational conditions leading up to the code setting. Understanding this background information is essential for accurate diagnosis and repair. The diagnosis will include checking wire connections, terminal conditions, and other related components, all essential for maintaining the vehicle's electrical system. This DTC P16BC specifically points towards potential issues with the alternator's FR terminal or the ignition power IGP circuit. The alternator plays a major role in powering electrical components and keeping the battery charged. Hence, any fault can lead to significant vehicle electrical issues. The corresponding 4P connector is the point where the electrical connections are made between the alternator and the vehicle's wiring harness. Core connections or loose terminals at this connector may disrupt voltage flow. Additionally, the alternator's mounting surfaces can develop corrosion over time, further impeding electrical conductivity. Proper functioning of the alternator is crucial, located typically on the front engine compartment. Therefore, careful inspection of these components is crucial for a successful repair. The possible causes of DTC P16BC include poor connections at the alternator, which can happen due to wear and tear or inadequate installation. Corroded mounting surfaces can also severely affect electrical performance and include oxidation that reduces the surface area for electrical contact. Additionally, open circuit issues can lead to a lack of electrical flow between critical components such as the alternator and fuses. These factors collectively contribute to the low voltage problem indicated by this DTC. It's important to check each of these areas methodically, as even minor connectivity issues can trigger this code. The diagnosis requires careful attention to detail to ensure a thorough understanding of every component's role in the circuit. The symptoms associated with DTC P16BC may include warning lights illuminated on the dashboard, especially the battery and charging system lights. Drivers may also experience various electrical malfunctions, such as dimming headlights or malfunctioning power accessories. Moreover, problems with the battery itself can arise, often showing signs of discharge or failure to start. Often, low voltage can result in erratic behavior from electronic control modules, leading to larger electrical issues. Recognizing these symptoms promptly can help prevent more serious damage to the vehicle's electrical system. Therefore, if these signs are observed, a timely diagnostic is necessary to avoid further complications and repair costs. The first step in troubleshooting DTC P16BC involves a thorough inspection of the connections at the alternator's 4P connector. Loose terminals or poor connections can often be the source of low voltage issues. It's essential to ensure that all pins are securely fastened and free from corrosion, as this can significantly disrupt the electrical flow. If the connections and terminals are effective, you will proceed to the next step. However, if issues are found, immediate repairs should be undertaken to rectify these connections. Always remember, a solid electrical connection is fundamental for maintaining the integrity of the vehicle's power supply. Taking the time to inspect and repair these aspects will pay off in ensuring efficient operation. In this second step, the focus shifts to the alternator's mounting surfaces for signs of corrosion. Corrosion can impede the effectiveness of the alternator by reducing its ability to ground properly, which is critical for performance. Removing the alternator may be necessary to perform a thorough inspection and cleaning. If corrosion is found, it is vital to clean all mounting surfaces meticulously and ensure they are free from debris or oxidized materials. This step not only helps in restoring proper grounding, but also prolongs the life of the alternator and improves overall vehicle performance. Once cleaned and the alternator is reinstalled properly, you can advance to the next steps in troubleshooting. Turning the ignition switch to the on-to position is crucial for subsequent steps in troubleshooting. At this moment, the vehicle's electrical system is activated without starting the engine, which allows for diagnostic tools, such as the HDS, Honda Diagnostic System, to interface with the vehicle's onboard computer systems. Clearing the diagnostic trouble codes should be performed next, as this prepares the system to re-evaluate the conditions that triggered the initial DTC. Using the HDS tool enables technicians to interact with vehicle data effectively and monitor changes after repairs are made. This standard procedure helps to understand the current state of the vehicle's systems, ensuring that any further actions taken are based on updated information. After turning the ignition to the on-to position, the next step is to clear the DTC using the HDS tool. This action resets the DTC status and allows for the next evaluation to take place under controlled conditions. It's essential to note that merely clearing the code won't solve existing issues. The vehicle must be monitored to ensure the problem does not recur. Following the DTC clearing, it is time to start the engine. Keeping a close watch on the vehicle's instrument panel, any warning lights or anomalies during the startup phase can provide insights into the health of the electrical system. Properly resetting and starting are key foundational steps in confirming the integrity of the alternator and associated circuits. Once the engine is started, it is vital to ensure that specific operational conditions are implemented. This includes turning on the air conditioning, setting the temperature control to maximum cool, and activating the blower fan at the highest speed. Additionally, the rear window defogger and headlights should also be switched to high beam. These actions demand maximum load from the alternator, allowing for a comprehensive assessment of its performance under stress. Holding the engine speed at 2,000 RPM for 1 minute while maintaining these conditions provides useful diagnostics. This controlled environment is critical for evaluating the alternator's ability to supply sufficient voltage when under load, which directly relates to the health of the vehicle's electrical system. In this step, the technician must check for either pending or confirmed DTCs with the HDS again after conducting the load test. If DTC P16BC is still indicated, it suggests that the issue persists, pointing directly to a problem with the alternator or associated circuits. Documenting this status is crucial for further diagnosis or if the vehicle was repaired previously. If the DTC is no longer present, it could indicate an intermittent failure. This means the system is performing adequately at this moment, but the problem could reoccur. Therefore, it's vital to go back and check for poor connections or loose terminals at the alternator once more. Each diagnosis step builds upon the last. Thus, thoroughness in every check is paramount. Turning the ignition switch to the lock position allows you to safely disconnect the alternator's 4P connector. This step is crucial to preventing any accidental electrical shorts while altering connections. Disconnection allows for direct measurements of voltage, essential in diagnosing the health of the alternator. After detaching the 4P connector, the ignition switch must be turned back to the on-to position, creating a pathway for power through the vehicle's electrical system without starting the engine. This setup is necessary for the next step in testing voltage, where precise readings can be obtained to evaluate the circuit integrity directly. The next critical step in troubleshooting is to measure the voltage between alternator 4P connector, terminal number 1, and body ground. This step directly assesses the function of the ignition power, IGP circuit. If battery voltage is present, the circuit is likely intact, and the problem may reside within the alternator itself. In contrast, if no battery voltage is detected, this suggests an open circuit may be present, potentially in the wire connecting the alternator to the number 3 alternator fuse, 10A, found in the under-dash fuse relay box. Effective communication of power between these critical components is vital for the alternator's operational capacity. Ensuring a thorough measurement and understanding the electrical flow is essential for a successful repair and diagnosis. After completing all repairs concerning DTC P16BC, it is crucial to verify that all are properly executed. Confirming that all connections are securely fastened, terminals are clean, and the alternator is mounted correctly provides assurance of quality work. Following this, recheck the DTC status using the HDS to ensure that the original code does not reappear. Conducting a final test of the electrical system under normal operating conditions ensures that everything is functioning as expected. This final verification step is essential to ensure customer satisfaction and avoids returning for the same issue shortly after repair. Thorough verification helps to establish trust between the technician and the vehicle owner, ensuring reliable vehicle operation. Preventive maintenance is key to avoiding future occurrences of DTC P16BC. Regular inspection of electrical connections is essential to identify any signs of wear or corrosion that can lead to larger electrical issues. Implementing a schedule for cleaning any identified corrosion at terminal connections or mounting surfaces will also help in maintaining optimal performance. Regularly checking the alternator during routine service can prevent performance drops that may initially be undetected. Owners should be proactive. Keeping track of electrical system performance can significantly reduce costly repairs down the line. Practicing strong preventive maintenance habits will enhance vehicle reliability and longevity. In summary, DTC P16BC indicates a low voltage issue regarding the alternator's FR terminal circuit or the ignition power IGP circuit. This troubleshooting process demands thorough inspection of connections, components, and circuit integrity. Correct identification of poor connections, corrosion, or open circuits is essential for effective resolution of the issue. Each step in the diagnostic process is critical and builds towards a comprehensive understanding of the vehicle's electrical system. Regular preventive maintenance is also emphasized, serving to identify potential issues before they escalate into major concerns. Maintaining a proactive approach will ultimately prolong the lifespan and reliability of the Honda Civics electrical components. Please like and subscribe to the channel. See you next time.